Hello, welcome to my channel. In this video I'm gonna take on a practice exercise problem. So let's get started. The problem is given here. So in this problem we are gonna have to calculate the circulation uh, of this figure for the vector this. So basically we're gonna have to find the line integral of this closed loop, and that's it. So let's get started. So before we get started, let us first understand what line integral is. In vector calculus, line integral of any vector is, say, any vector a. So line integral for this vector is, this is called line integral a with differential length. So this is the line integral. So the full definition is that we integrate all the tangential parts along the um, along the designated curve, L. Say L is the curve or path, so we have to integrate. So L, say L is, this is a closed path or any path. So say this is L, so we have to integrate along this path all the tangential components of A. So the components which are tangential to this path, we have to integrate those from, and we have to integrate from A to B. So this is the line integral for open loop path. So if the line, if the path is closed loop like this, say this is A and this is B, so we can apply our definition for line integral for closed loop. So for closed loop path it will be like, so so if we take the line integral from of the vector A along a closed path, it will be, the line integral will look like this. So the integral symbol with a circle with included with it. So for line integral along a closed loop of a vector is called circulation. For this closed loop we can say, if we want to integrate this in segments, because it's a closed loop and we are integrating this part by part, say from B to A, so B to A plus A to B, so A dl dl. So this is also a form of line integral. We can also get the answer by integrating in segments. So this is the basic understanding of line integrals. Let us apply this immediately. So here we can see a closed loop L, uh, or closed path L. So, and given vector A in cylindrical form, rho cos phi A rho plus z sin phi Az. So there's no phi component here, so phi is constant, and here it's 60, so which is phi. So phi is obviously mainly constant. The vector A has no phi. So for A vector it is not changing, but in this figure there is a change in phi from, say, so rho is changing from 0 to 2, and phi is changing from 0 degree to 60 degree. So so to get the line integral along the path, let us first uh, divide this line integral into segments. So say, so for this is obviously circulation A and differential length, because this is a line integral. We say say L1 plus L2 plus, so, and L3. DL, 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 and A. So we are gonna integrate and get the result by in segments by doing part integration. So say the first part is from 0 to 2. So say for the first integral, um, L1, only rho is changing and phi is 0 here. Phi is 0 degree for L1 path, phi is 0 degree. So the integration is, and the differential length is d rho. So along this path only the component a rho is changing. So ADL means, so ADL A dot, so this is dot product, and we said that uh, line integral is the integration of the tangential parts along the path or the this given curve L. So ADL is A d rho, which will give us d rho arrow. So d rho in the direction arrow. So so arrow is we have A has tangential part in the direction arrow, this part. So we are gonna take rho cos phi d rho, because we are getting only the we are doing a scalar multiplication to get the tangential part, and we got our uh, terms. Now let's integrate this along path L1 ADL, which means 0 to 2 rho cos phi d rho, and phi equals 0 here. So, and rho is the it's basically this, and phi is also phi. If we consider the phi as uh, angle, or in the direction it rotates x in the plane x and y, so it's also rho phi is also vector sum of x and y. So these two are rho and phi are vector sum of x and y combined. So in this case, so cos 0 degree cross half rho square 0 to 2, so which will give us cos is 1 and half and rho square, so 2 square minus 0, this will eventually give us 4 by 2, which is 2. So we have found our first integral for the line. So we have integrated from 0 to 2 in the direction x. Now we want to find in this arc. So to find this in this direction, the differential length dl is rho d phi in the direction a phi. If you don't understand what this relationship is, where did it come from, you can watch my previous vector calculus problem, practice problem solving video. I have discussed this in that. So basically, um, this vector is in cylindrical coordinate system, and in cylindrical coordinate system the differential length, and we are doing the we are solving a line integral problem, so we need to know what the differential length is. So here differential length is rho d phi a rho for this arc. So if we get the try to get the value a d l, so there is no phi component, so a has zero value, zero component in this arc, along this arc or along this curve. So along this L2 path, this arc or this curve, and a has no tangential component, a the integral is 0, we have no value. Now along this path L3, the differential length is dl d rho in the direction a rho. So obviously we would get ADL equals rho cos phi d rho again, but here phi is 60. So here phi is 60, it is constant, rho is being changed, rho is changing from 2 to 0. So L3 ADL is 2 to 0 rho cos 60 d rho, which is cos 60 is half rho square is 2 to 0, which is so 1 by 4 cross 0 minus 4, so minus 1. So for our full closed loop integration, the full line integration, so after integrating along all the paths we have designated, path L1, L2, L3, which is the full circulation, and we got our values. Along L1, the vector had the value after integration, um, 2, and along L2 path the vector had no tangential component, thus no value, and along the path L3, this path, uh, vector A gave us the value after integration -1. So the result of the full uh, closed loop integration is 1. So this is the answer. Hope you understood my explanation, and there is no differential change or variation in the z axis, which is this, or say this. So this component is basically constant, there is no z, there's no value along this path for the vector.